Hello, and welcome to Agrosive Physics. Today is day 67, and what we're going to look at today is a single problem dealing with moving a piano from the ground to a platform using different ramps. Now, the question is, which of the setups is going to use the least amount of work? And what I want to discuss briefly is the concept of a simple machine. Now, simple machines allow us to perform tasks that we might otherwise not be able to do physically. Using a pulley or a ramp or a screw or a wedge will allow us to effectively increase our effort in order to achieve a goal. A ramp is useful if we're not strong enough to lift an object. So in this case, we're going to have a piano where we lift it vertically onto a platform 2 meters high. Now, that's virtually impossible to do for most people. In fact, we would probably need to use a ramp. And what we're going to do for this set is do 3 different situations. One where we lift the piano vertically and we figure out the work done there, and the other 2 where we use ramps of varying length. When you use ramps, it makes it easier the longer the ramp is. So the lower the angle, the easier it's going to be to push the object up the ramp. The problem is there's a trade-off for that. And that's what the basis of simple machines is. If you want to use a pulley and you want to lift something that's extremely heavy with a pulley system, well, you're going to have some trade-off for being able to lift it. If you could only apply a force of 100 newtons and the thing requires 1,000 newtons, you're going to need to multiply your strength, or you're going to need to use a simple machine to multiply the effort that you're given to lift that object. But in everything, there's a trade-off. You can't get something for nothing, so the byproduct is going to be that you have to pull the pulley a lot farther. In our case, we're going to do lifting the piano to the 2-meter platform, pushing it up a ramp, and then pushing it up another ramp. And the question of today is, which requires more work? Let's get the whiteboard out and solve that problem now. Now we're going to look at a work problem where we're trying to get a piano from the ground onto a platform. So this is the piano and this is the platform. And the piano is going to get to the top of the platform in one of 3 ways. The first way is we're going to lift it directly up. So that's method 1. The second method is we're going to use a ramp and we're going to push the piano up the platform or up the ramp, and then we're going to reach the platform that way. The third problem is going to have an even longer ramp, and we're going to determine how much work it takes to push it up that ramp. Now, in each case, we have the same piano. So the piano is going to have a force of gravity that's constant for all 3 trials. The amount of force that we have to apply may differ. But let's find the force of gravity. First of all, it says it's a 250 kilogram piano. So 250 times 9.8 meters per second squared should get us the force due to gravity that we have to overcome. 250 times 9.8 yields 2450 newtons. Okay. Now, in the first case, we're lifting it directly up. The platform is 2 meters high, and I'm applying all the force straight up. Well, the work, I'm just going to put 1 for method 1, is force times distance, which is 2450 times 2 meters. I had to lift it 2 meters high. And you get 2450 times 2, 4,900 joules. All right, how does the second and third situations differ? Well, on the second one, we have the same platform, which is 2 meters tall, and the hypotenuse, which is the ramp, is 3 meters long. So what we have to actually do is push it at an angle. And the angle can be found using sine theta equals 2 meters over 3 meters. Well, if we do 2/3 and do the second sine second answer, we get 41.8 degrees. If we have 2 and then 4, which is our other example, sine theta equals 2 meters. That's still the height, but now we have a longer ramp, 4 meters. 0.5 second sine second answer is going to get me, well, 30 degrees. And we already knew that. Sine of a half is 30, or inverse sine of a half. Now, when we're pushing something up a ramp, what force do we have to overcome? Well, if this is the ramp, we blog or break legs of gravity, and we get F parallel, F perpendicular, and force of gravity. Well, the one pointing down the ramp that we have to fight is F parallel. Now, how do we find F parallel? F, G, sine theta. So what we're going to do is use the 41.8 and the 30 as our values with sine to figure out the force applied. So for work of 2, the force I need to apply is 2450 times the sine of 41.8 degrees, and then I'm going to multiply that number times 3, which is the total distance I have to move it. Now, if we think about it, the sine of 41.8 is 2/3. So all we have to do is replace sine of 41.8 with 2/3. So it's going to be 2450 2/3 times 3. Well, the 3's cancel, and we're left with 2450 times 2, 4,900 joules. Wait a second. Interesting. For the third one, we have 2450 newtons times the sine of 30 times 4. Well, we know the sine of 30 is a half, so it's 1/2. 4/2 ends up being 2 again. So the answer for this one becomes 4,900 joules as well. So, which one of these methods requires the most amount of work? And the answer is none of them. They all require the same amount of work. Now, of course, we are neglecting friction. If friction were involved, we would have to probably push a little harder than the minimum in order to move them up the ramps. And because the longer ramps would have more friction acting on them, it would probably be even more work for that. But in a frictionless environment, no matter how I get the piano from the ground to the platform, it does the same amount of work. So why use a ramp? Well, the reason we use a ramp is because as the ramp's angle gets lower and lower, it requires less force to push it up the ramp. I cannot lift a piano by myself, especially vertically. So I'm going to have to use a simple machine like a ramp in order to be able to move the piano in the first place. So the ramp's job is to make it easier. The trade-off, however, is that you have to push for a longer distance. And that's really the key to simple machines in the first place. Now, of course, this is without friction, but theoretically, the values for all three of these cases is 4,900 joules.